let's have a look at privacy now. We're going to dive into privacy. We've had a look at transfers. We've had a look at what a transfer on a blockchain looks like. And now what we're going to do is dive into how do we make it private and simple. And there's many examples of data that needs to be kept private. For the purposes of this webinar, we're going to split them into two buckets. And the first bucket is any data that does not affect the stored value on the blockchain. And we saw things like personal data in the poll, GDPR compliance. The fact that my name is Peter has no impact on any transaction I do in terms of the value, but I do need to, for purposes of KYC or anti-money laundering, I do need to put that kind of data into the transaction. So my name, my address, some kind of reference to my ID, for example. And then there's data that does affect the stored value on the blockchain. And it's important that we keep these things separate because the way we handle privacy around these two things is quite different. Let's have a look at it in a different way. So let's say Bob, instead of sending Alice money, he took a photo while he was on holiday at the beach and took a photo, and he decided he wanted to send it to Alice. So he wants to send Alice his picture. He sends it across. Now, what happens typically is they both have a copy of that picture of the data, and they can both send it on to other people. And this is fine for most shared data. But when it comes to value in a shared network, like a blockchain network, it's not fine at all. So if we have a look at the value, the data that affects value, we see that when Bob sends the $100, he cannot retain a copy of it. Both he and Alice need to be 100% sure that the money moved. It wasn't copied, it was physically moved from Bob's account to Alice's account. And it's not just Bob and Alice that need to know that. Everyone on the network needs to know that. And the reason that everyone needs to know that is because this transaction doesn't happen in isolation. They are not passive observers. They're actively involved in the ledger themselves, and they may participate in future transactions. So if Charlie receives money, or Bob tries to pay Charlie with the same 100, Charlie needs to be sure that Bob no longer has access to that 100 and Alice does have access to the 100. This becomes really important when you start looking at how do we make these things private. So let's go back to our example with the debits and the credits. Now, data in this situation that does not affect the stored value is things like name, the fact that Bob was paying $100 for a second-hand iPhone. Data that does affect the stored value, so that's value transfer, is obviously the transaction amount itself, and then the initial and the final balances. Those are all intrinsically involved in the value that is stored on this blockchain network. Now, there are many ways to make data private on the blockchain, and some of them work really well for data that doesn't affect the value, and others work well for data that does affect the value. So the first thing we can do is obviously limit who has access to that blockchain. And the Kaleido team are with us here today, and they're going to talk a little bit about this at the end. They have a lot of really good tools for limiting who has access to a permissioned blockchain network. And that's kind of your first set of defenses, if you like. So we're going to limit who is allowed to actually transact on this blockchain network. The second way we could do it is to put the data onto a private channel between only the nodes involved in that transaction. And we have many examples of that: Whisper, Swarm, Constellation, or Tessera, and Quorum now, and Kaleido off-chain communication. So there's lots of ways of setting up private channels. The Pantheon guys are also on the call. They're going to talk a little bit about some of their sidechain work that they're busy with, and that's another form of doing a communication just between a set of actors on the network, a private channel, if you like. We can send the data via an unrelated channel, so completely off-chain with some kind of reference back to transactions, and we can send some data via email, for example. We could send it by secure email, only to the specific counterparties who need to see it, and reference that back to the transaction. We could also encrypt the data in the transaction. The only problem with blockchain networks is that they're immutable. The transaction stands forever, or as long as the ledger is up. And that's generally not a good idea because we know that people can eventually decrypt data. So it's not a good idea as a standalone method, but it certainly works really well in combination with some of these other methods. So what I'm going to say up front is the data that does not affect the value, the balances, the transaction amounts, anything that doesn't affect the value transfer, so all the personal data, any metadata associated with that transaction. Obviously, once we've secured this permission, and we're speaking specifically about permission networks, we've secured the network, we know who's on it. but any data that is metadata that is related to a transaction but doesn't affect the value of the transaction or the value of the whatever value is stored on the blockchain, we put that in a private channel and we can encrypt that for good measure. Most private channels have built-in encryption techniques or encryption tools, and that's a really good way. So Bob's full name, Bob's address, the fact that he's buying a second-hand phone from Alice, that doesn't have to be distributed across the entire blockchain network. That can be just put onto a private channel between Bob and Alice. And that's a really, really good way of solving that problem. And so non-value related data on a blockchain, the best way to do it is to pop it on a private channel and communicate it just between the counterparties who need to see that data. The rest of the network just has no idea that it's even there. There's no way that they can decrypt it because they physically just don't have access to that data. Now, data that does affect value, or the balances on the blockchain, this is a bit more interesting, and I want to explore a little bit around this. And this is really where the meat of the talk is today, the webinar. A transaction, every transaction in terms of the value of that transaction, the balances, the transaction amounts, every transaction is linked to the one that happened before it, and it will be linked to the one that happened after it. So transactions are linked together. Therefore, it's very difficult to use private channels to do value transfer or to keep value transfer private from the rest of the network in a simple way. And I'll explain why now.